Hello students, today's agenda is to graph rational functions, and I will be doing the second part of 7.5. I will be doing that third example where you have to factor. Today students will be able to graph rational functions with removable discontinuities, but remember that this time we'll be factoring. And if you haven't, you definitely need to first go ahead and see this video where we have a rational function, something like this, where you cancel to find the removable discontinuities. This example, it has not been factored. They're not giving us the factors, they're giving us a trinomial divided by a quadrinomial. And so the first thing that we want to do is to factor those polynomials. Whenever you have a quadratic equation, what you can do is see if you can find two factors that multiply equals 6, but when you add them, this tells me that I'm going to add them and not subtract them. It's going to be positive 5. And so 1 times 6 is 6, but 1 plus 6 is 7, not 5. The other pair of or factors of 6 is 2 times 3 is 6, 2 plus 3 is 5. So yeah, those are the factors. So in the numerator, I'm going to put x plus 2, x plus 3. For this one, since it's a quadrinomial, you can try grouping, but myself, I can see that the greatest common factor in here is x squared, and I'll end up with x plus 6. But then in here, if I find a factor in here, it will be only 1. I will not get x plus 6 because it's going to be 11x plus 6, so no. So if grouping doesn't work, what you can try is just find all the factors of that 6. Only because this is a 1, the factors of 6 is 1 times 6, 2 times 3. But remember that we're going to be working with the positive and negative of those. And so for synthetic division, you put the coefficients and constant. So 1, 6, 11, and 6. And so the first one that we're going to try is x plus 1, okay? X plus 1. And so to have that, I'm going to put the opposite of plus 1, so it's going to be negative 1. Then you're going to bring this 1 down and start multiplying. So negative 1 times 1 is negative 1. I combine this, 6 minus 1 is 5. And I repeat the step of multiplication. Negative 1 times 5 is negative 5. I combine this, and it's going to be positive 6. Then I do the same thing. Negative 1 times 6 is negative 6. I combine, and I get 0. Whenever I get 0, that means that the remainder is 0. And therefore, this will be a factor, and this will be the other factor, okay? So x plus 1 times, we put that as a coefficient, but we don't need to put coefficient 1. And we put x. Now we're not going to get x cubed because we already took one of those x's. We go to the next degree or exponent, which is squared. The 5 will be the coefficient of x with no exponent or exponent 1. And the 6 will be my constant. Now, as you can see, x squared plus 5x plus 6, x squared plus 5x plus 6, that means that this right here can factor to become these two factors, okay? So I just wanted to rewrite x plus 1, and then this right here is the same as this one, so just bring those factors right there. X plus 2 times x plus 3. Again, why? Because this 6 is 2 times 3, and 2 plus 3 is 5. Okay, x plus 2, x plus 3. Okay, so now that I have those factored out, the next step is to cancel. See what is removable. Oh, x plus 3 divided by x plus 3 is 1. X plus 2 divided by x plus 2 is also 1. So I can just write this new rational function in simplified forms. It's going to be 1, right? Because when we divide that, it's 1 over x plus 1. So that's my new rational function. And so the next step is to find the removable discontinuities. And so by doing that, we're just going to get each one of these factors. We're going to have 2 wholes this time. Equal that to 0. And after you find the solution of x, or the answer for x, we replace it in this simplified rational expression so that we can find the value of y. Okay, so subtract 2 from both sides. X is equal to -2. And for the other whole, we're going to subtract 3 from both sides, and x will be -3. Now we replace that value into our expression, and so y is equals to 1 over -2 plus 1, which is 1 over -2 plus 1 becomes -1, and positive divided by negative is -1. Okay, so the first whole is at -2, -1. Okay, that's my first whole. For the next one, I get y is equals to 1 over -3 plus 1. 1 over -3 plus 1 is -2. And so it's at -1/2. So -3, -1/2. So that's my next whole. Okay, now let's find the other parts to graphing when we don't have a table. Okay, so the y-intercept, remember that x is equals to 0, so y is equals to, we substitute that by 0, 1 over 0 plus 1, 1 over 0 plus 1 is 1, and 1 divided by 1 is 1. So this is my y-intercept. It's going to be at 0, 1. That's my y-intercept. For the x-intercept, y is equals to 0. And so we put 0 is equals to 1 over x plus 1. All I did was replace y with 0. If I'm dividing by this expression, I'm going to multiply by the expression, and this cancels, and so we say 1 is equals to 0 times anything will always be 0. And this does not make sense. 0 is not equal to 1. So what does that mean? That there is no x-intercept. Okay, no x-intercept. And so it will not cross the x-axis. For my end behavior, meaning where on y does it approach, and so to find that, we use the rule that we used in the last videos. And so we look at the expression 1 over x plus 1, and it says if the degree, hopefully you have this list. If not, again, I recommend that you do see the previous video, because this will make sense. The only difference between the other one and this one is that this one has the wholes. Okay, so it says if the degree of the denominator is greater than the numerator, degree refers to the exponent. Since we don't have x in here, it means that it has x to the 0, because anything to the power of 0 is 1, and it's that one right there. So the degree is bigger or greater in the denominator than the numerator. So what's going to happen? The asymptote is at y equals 0. Okay, so because we have x to the 0 and then x to the 1, this is greater, so y equals 0. For the end behavior is the same as the horizontal asymptote. Okay, and what about for the vertical asymptote? For the vertical asymptote, remember that we get whatever is in the denominator and equal it to 0. So we have x plus 1 equals 0. Why? Because we get whatever is in the denominator equal it to 0. So minus 1, x equals 0 minus 1 is negative 1. So that's my vertical asymptote actually. Whoops, it's a little crooked. It's a lot crooked. It's the curve of the, okay, so that we don't forget, let's start with our holes or removal discontinuities. I'm so sorry. We'll begin with those holes. -2, -1. -2, -1 is right there, so it's an open circle. And then we have -3, -1/2, -3, -1/2. So that's another hole that you can barely see, but let me empty it right there. And so my graph will go through the points in there, but will not include those points right there. So now after the discontinuities, let's find our asymptotes. Y will be equals to 0, so that means that my asymptote will be right on the x-axis. The other asymptote, the vertical asymptote, is at -1, so it means that it goes in here. Okay, and so the y-intercept is at 0, 1. 0, +1 is right there, and there is no x-axis. Why? Because my graph will go right here and it will approach the x-axis, but it will never cross it. Okay, so remember this part, we do it with pencils because we're going to be creating a table, and after our table we can just go over it in the real points. Okay, remember my graph for rational will always approach the asymptotes but will not touch it, will not touch them actually. Also, it will go through except it touches in there, but it's not including those holes. Okay, okay, something like that. And so if you don't need to create a table, that's all you have to do. Just look for the x and y intercepts, the horizontal asymptote and the vertical asymptote, okay? It refers, when we're talking about the horizontal asymptote, it refers to where is it going on the end behavior. So in the positives, it's just approaching 0. On the negatives, it's also approaching 0. Okay, now for our table, remember how to choose the points. In the middle, I will put the vertical asymptote, which is at -1. Then I add and subtract 0.5 on either side. So in here is going to be -0.5 or -1/2. Then in here it will be sort of 1 and 0. And I have it backwards actually. 0 and 1. Why is that? Because this is my vertical asymptote. I do half away from it and 1. On this side, I will put -1 and 1/2, -2 and -3. Or since we have that discontinuity for -2 and -3, what you can do is just choose another one, which is maybe -4. Okay, so let's just choose -4 on that side since we already have 2 points in there and they're actually empty. And that way we remove one less. Okay, so we copy the simplified, which is y is equals to 1 over x plus 1, and start substituting our values. So y is equals to 1 over 1 plus 1. 1 plus 1 is 2, so it's just 1/2. For 0, y is equals to 1 over 0 plus 1, And this is even the y-intercept, which we already have as well, but that's okay. So 0 plus 1 is 1, which is 1 divided by 1 is 1. And then y is equals to 1 over negative 1/2 plus 1. And so we put 1 over, okay, so 1, negative 1/2, and 1, it means I have 1 and I eat 1/2, so I end up with 1/2 in here. If we remember from fractions and division, you just put it over 1, the whole number, put it over 1, and multiply this one. 1 times 2 is 2, 1 times 1 is 1, and 2 divided by 1 is 2. Or the other way around, or the other way to see it is, how many halves go into 1? How many halves can I get from 1? Oh, I get 2 of them. Okay. Or the last resort is to divide 1 divided by 0.5, because 1/2 is 0.5, and that's 2. In here, for the vertical asymptote, you have 1, and then negative 1 plus 1, 1, negative 1 plus 1 is 0. We can never divide anything by 0. Why? Because 1 divided by 0 gives me error. Okay, so whenever we get that, we put undefined. And what does that mean? It's because we're looking for a number that multiplied times 0 gives me 1. Nothing multiplied times 0 would give me 1, okay? And so we put undefined. That's why my graph doesn't touch that asymptote, because it's undefined. There are no solutions in that line. Okay, the next one is going to be y is equals to 1 over, replace the value of x by negative 1 and 1/2 plus 1, put 1 over, if I owe $1.50, but I pay $1, I still owe half of $1. Positive divided by negative is negative. How many halves go into 1? How many do I get? I get 2 of them. So negative 2. Again, if you want to use your calculator, you put 1 divided by, put 0.5, 1/2 is 0.5, and put the negative afterwards. Okay, this one right here. After you put the 0.5 equals, and you get negative 2. And the last one, y is equals to 1 divided by negative 4 plus 1. 1 over negative 4 plus 1 is negative 3. So negative 1/3. Okay, negative 1/3. Okay, now that we have those values, we can see how close or far we were with our graph. So 1, 1/2 from the origin, 1, 1/2 is around there. Good job. 0, 1, 0, 1, we already had that one. Negative 1/2, negative 1/2, positive 2. Positive 2 is right there. Not bad. Okay, undefined, that means that there are no values in here. And then for the next one is negative 1 and 1/2, negative 1 and 1/2, negative 2. So 1, 2 right there. Negative 4, negative 1/3, negative 4, 1/3 around there. So we were very close with this one, not like the previous one, but that's only if you need to have points. So that's going to be our graph. And remember that this approaches 0, but it will never touch it. Okay, here these are my holes, right? These create holes because we got rid of those values. Whoops. They cancel each other because they're both in the numerator and denominator of our rational function. Okay, so those holes right there, those are created because we have them in the numerator and denominator. With this graph, we end our lesson. If you can give us a thumbs up, subscribe around here. This is the link to the entire unit. Here will be the next lesson. Now you're able to do 7.5 and have fun.